Hello guys and welcome to today's video. Right guys, today's video we are going to be looking at inverse Laplace transforms. So in the last video we were looking at taking Laplace transforms of functions. This time we're going to be doing essentially the opposite. So we'll be taking our answers in the previous video and then putting them back to the question that was essentially asked in the previous video. So we are essentially working backwards. Now before I start guys, just a quick point actually. So I will leave here a link of the description here for the formula book actually in my description below. Okay, so all these answers that I got actually is from the formula sheet that you will be allowed to use here for your summer examinations. Okay, at university. So it's aimed at university level students. Okay. Right guys, okay, so we're going to be looking at examples actually. So example 1 actually, so the inverse Laplace transform actually of 1 over s. So we know here that previously the Laplace transform of 1 is 1 over s. Therefore, working backwards by logic, the answer will just be 1. So the inverse Laplace transform of a over s, it will just be a. Okay, example 2 guys, the inverse Laplace transform of 1 over s squared. Okay, well we know the Laplace transform of t is 1 over s squared, so working backwards the answer will just be t. Example 3 guys, the inverse Laplace transform of 2 over s cubed, it will be t squared. Okay, 2 factorial, sorry, 2 factorial just means 2 times 1, okay? Example 4, the inverse Laplace transform of 1 over s minus 7 is e to the 7t. Example 5, the inverse Laplace transform of 2 over s plus 4, it will be 2e to the minus 4t. So remember, when it's 1 over s plus a, it will be e to the minus at. Okay, so yeah, just be careful with your signs in that one. Right, guys. Example 6 actually. So the inverse of 1 over s cubed. Now we know here that the inverse of 2 over s cubed, so 2 factorial, it will be t squared. Okay, 2 factorial actually. But we have a 1 here. Now, the only way to actually make that possible is that I'd have to divide this by 2. Okay, which is the same as multiplying by a half. Because we want a 1 there instead of a 2. So to make that true, I have to divide, this by a half. Okay, so it's t squared over 2 or a half t squared, guys. Okay, so obviously be careful. So sometimes it will require a bit of manipulation actually, yeah. So if you're not sure actually, so what I did there was, so it's the same as doing the inverse Laplace transform of 2 over s cubed, but we want a 1 there. So to cancel the 2 on the top, I had to multiply by a half. Okay, or essentially that, or essentially divide by 2. Okay, example 7, guys. The inverse Laplace transform of s over s squared plus 9. Sorry, that isn't s there, guys. So sorry about my handwriting. It'll be cos 3t. Okay, if it was a number on top of here, it would go on as a multiplier. Okay, if that makes sense. So if it's inverse Laplace transform of as over s squared plus of a squared, then it would just be like so it would be whatever the number is in front actually, it will come out as a multiplier. So for example, had it been like a 2s, it would have been a 2 there. If it was a half there, it would have been a half, and so on and so forth. Right guys, example 8, the inverse Laplace transform of 2 over s squared plus 4, it'll be sine of 2t. Okay, example number 9, the inverse Laplace of 1 over s squared minus 1, it will be sine t. The inverse Laplace transform of s over s squared minus 1, so example 10, will be cos t. Okay, right guys, so that's obviously 10 examples actually. There are more here, so I would advise you to check out the link here in my description actually for anyone, if you're looking for more example for questions for inverse transform, and more Laplace transform questions. Okay, these unfortunately, they are not all of them actually, but they were the ones that I could fit onto obviously my whiteboard today. So please check out the description here for that in the description below. Also, guys, right, last two points actually. Right, so Khan Academy, Patrick JMT and TL Maths. So they're brilliant videos actually for these sort of topics. Okay, so yeah, particularly like Patrick James, actually, that they're actually like brilliant videos. Okay, so please check them out actually. Okay. Okay, and thank you for watching, guys. Yeah, but please stay safe, actually. Yeah, and I hope everyone, yeah, is doing okay, actually. And I hope anyone that has an exam, actually, yeah, obviously next month at university, or yeah, or like any sort of form of assessment, then I wish you obviously all the best, and I hope things go well, actually. Yeah, and I hope you stay safe, actually, and stay well, and follow the NHS guidance. Okay, thank you for watching, guys. The next video, actually, that I'll be filming will be on partial fractions. Okay, so tune in, actually. Thank you for watching, and I'll speak to you soon. Bye now.